Hello everyone, myself Sheikh Muhammad Nasir. Currently I am pursuing BTech second year in CSM department at Srinivasa Ramanujan Institute of Technology. So today I am going to explain you about test of significance for true proportions. So it is a concept of probability and statistics. Let's get into the topic. Test of significance for two proportion. Test of signification for two proportion. The test of significance for two proportion is a statistical hypothesis test used to determine whether there is a significant difference between the proportions of success in two independent groups. This test is often applied in cases where we compare success rates, response rates, or proportions in two different populations. The test of significance for two proportions is nothing but it is a statistical hypothesis test used to determine whether there is a significant difference between. So it is used to determine whether there is a difference between proportion of success in two different independent groups. This test is often applied in cases where we compare success rates, response rates, or proportions in different population. Procedure: let P1 and P2 be the sample proportion in large random sample of sizes N1 and N2 drawn from the two populations having proportion P1 and P2 to test whether the two samples have been drawn from the same population. So here the procedure is given that let's assume that P1 and P2 be the sample of proportions in two large random sample sizes, where two large random samples of sizes N1 and N2 drawn from the two proportions having proportions P1 and P2. So here to test whether the two samples have been drawn from the same population or not. So to solve any statistical hypothesis problem, we have several steps. So the first step is null hypothesis H0, that is P1 equal to P2. Alternative hypothesis H1, P1 not equal to P2. So here null hypothesis means we are simply accepting the given statement. Alternative hypothesis is nothing but we are rejecting the null hypothesis and accepting the alternative hypothesis, that is rejecting H0 and accepting hypothesis H1. Test statistics. There are two ways of computing a test statistic. First one is when the population proportion P1 and P2 are known. In this case, Q1 equal to 1 minus P1 and Q2 equal to 1 minus P2, and P1 and P2 are sample proportions. Hence the test statistics Z equal to P1 minus P2 by root of P1 Q1 by N1 plus P2 Q2 by N2. When the proportions P1 and P2 are not known but sample proportions P1 and P2 are known, so that is Z equals to P1 minus P2 by root of PQ into 1 by N1 plus 1 by N2, where P equal to N1 P1 plus N2 P2 by N1 plus N2, where Q equal to 1 minus P. Question: on the basis of their total scores, 200 candidates of civil services examination are divided into two groups, and upper 30% and remaining 70% consider the first question of the examination. Among the first group, 40 had the correct answers, where among the second group, 80 had the correct answer. On the basis of these results, can one conclude that the first question is not good at discriminating ability of the timing being examined here. So the solution of this problem is the total number of candidates equal to 200. Given first sample size is N1, that is 30 by 100 into 200, that is N1 equal to 60. Second sample size N2 equal to 70 by 100 into 200, that is N2 equal to 140. So here we are calculating the first sample size and second sample size. So here first sample size is N1, that is equal to 60, and the second sample size N2 equal to 140. So let P1, P2 be the proportion of correct answers both first and second group respectively. So here P1 equal to 40 by 60, that equal to 0.66. P2 equal to 80 by 140. So P2 equal to 0.571. First step is null hypothesis H0. P1 equal to P2. Alternative hypothesis H1. P1 not equal to P2. Level of significance alpha equal to 5%. Test statistics Z equal to P1 minus P2 by root of PQ into 1 by N1 plus N2. P equal to N1 P1 plus N2 P2 by N1 plus N2. So P equal to 60 into 6.66 plus 140 into 0.571 divided by 60 plus 140. So that equal to P equal to 0.599. So Q equal to 1 minus P, that is 1 minus 0.599. So that equal to Q equal to 0.401. So Z equal to 0.66 minus 0.571 divided by root of 0.599 into 0.401, that into 1 by 60 plus 1 by 40. So that equal to Z equal to 1.17. Tabulated value for alpha, that is 5% in two-tail test, is Z alpha by 2, that equal to alpha here, alpha equal to 5%, alpha by 2 equal to 2.5%, that equal to 0.025. The tabulated value in this is in the above, it is a two-tail test problem. So we are dividing it into 0.25, 0.025, 0.025. So here we are drawing the normal distribution curve, and we are calculating this level of significance. So that is A of Z alpha by 2 equal to 0.5 minus 0.025. That is from 0 to alpha. 0.5 into 5 minus 0.025, that equal to 0.475. So Z alpha by 2 equal to 1.96. So here the tabulated value for significant alpha significance 5% is Z alpha by 2 equal to 1.96. 5. The fifth step is conclusion. That is conclusion Z equal to 1.17. So Z alpha by 2 equal to 1.96. Therefore Z less than or equal to Z alpha by 2. So accept H0. Thank you.